So I'm going to take you through a little interesting AI discovery, and I'll show you, kind of walk you through what I used the AI model for. And I believe we're using a Gemini model, or maybe it's a chat model, but I'm going to show you what I wanted to do. I wanted to get the AI to create a program for me. And so I started off with asking it a little question, and I'm going to show you the response and how it worked, and then how we ended up getting some code running, and it was pretty straightforward. And this actually gives us quite a bit of opportunity once we get this code running to play with it and just see what's possible. So we'll kind of jump into it. So I went ahead and asked the AI question. I said, can you tell me what library is needed in C++ to access the display? And now C++ is a programming language, and a library is basically a big compilation of pre-written code. And so the AI answered me, and it said, as a coding helper, we can do this a couple different ways. For GUI applications, you need to use one of these frameworks. And so I didn't know which one is best. I just picked one, and I asked it. I asked it a little bit more of a better question there. I said, I want to create a C++ application that accesses the display to create a simple fractal and plot points on a graphical plane. So that's a pretty straightforward question, and this is a problem that we would do in our first computer science course. And sure enough, the helper gave me some of the libraries that I could use, and these are libraries that are we can use one library, or we can use multiple libraries. And so I went ahead and asked it about this one, Simple Direct Media Layer. And so it went ahead, and I didn't ask it necessarily to produce the code, but it actually went ahead and produced the code that would create a fractal. And so, but then it went even farther. It told me how to actually install the libraries. And so, so what I did was I went ahead and did that. Now, I could install these libraries using the command prompt, but I wanted to go ahead and run a graphical user interface. And so I have my graphical user interface running. And the interesting part about that is that this is Linux. If I was doing this on Windows, I would have a completely different process involved. But I'm going to go into my folder here and look at my code, and I put it all in a folder called graphics. And so AI has at this point created a couple of different programs for me. He created a fractal program, and as you can see, here's the fractal code, and it just in roughly 3 minutes it generated all this code. And so I didn't even test it. I just looked at it and I said, okay, what do I need to do to compile this? I went ahead and installed the libraries. It gave me the compile code, as I'll show you. It told me how to install the libraries. It gave me a testing program so I could test the library, and that's the first one that and then it gave me the fractal again, and so it told me how to compile the code, and so I went ahead and did that. So let me show you what came out when I installed the libraries and compiled the code. First thing I did was I tested the library to make sure it was working, and The only thing that happened is that it generated an error right at the very first part, and it turns out that there was an environment variable that was not entered in and so I got an error message. I asked AI, what does this error message mean? And it actually said, oh, well, you need to use an environment variable to set this up. So I'm assuming that probably what will happen is when I test this graphic, it may throw an error. We're going to test the library. And actually, no, it didn't. It came up. This was the first test of the graphics library. And so I'm actually controlling the display right here. And then here was the code that it gave me for the fractal. And that's the Mandelbrot set. I would assume that if I wanted to use a different set, I could easily replace the function in there with another function. And then I went and I said, okay, here was the error. I said, you forgot to set a runtime environment entry. I received this error, xdg runtime directory. And then it told me, hey, this is how you do it. You got to add a directory for the software to live in. And so we did that. Not sure where that ended up. It's the temp runtime dash user. There it is. There's nothing in there. It just needed to have that folder in order to run. And so once I actually did this solution one, I did that, and I was able to compile the program. And so let's see. Sometimes the AI it goes above and beyond, and it's extremely helpful. But then I wanted to look at the library, and I said, what is the path of the directory? And so it actually told me to go look at the library, and told me where they would be, or where they could be. So very helpful when you start asking a question of a technical nature on a particular thing, okay? And then it tells me how to compile, right? So I can do that. And then I said, okay, here is my next task. I want to generate code that gives me a slowly rotating 3D cube along with random appearances of conic sections. Now, I didn't tell it anything about the speed of the rotation or the types of conic sections. I just gave it that prompt, and it came up with a very large program. I mean, it just took this about 30 seconds to write down this program, and there was only one little error, and the error was, I'll show you the error in the code. This is kind of interesting, but it turns out once I fixed this particular error, everything worked just fine. And let me get out of this. Let's see. Here's my code. vim conic. We'll go up and look at some variable declarations. And basically, here's what happened. The program created 3 variables that were going to make some parameters for the conic sections. And then it made some variables for the color. Now, color is usually denoted by RGB, red, green, and blue. And so this was originally a B. And the program threw an error when it got right there, and it said, you cannot have 2 variables named the same. And so my edit was simply to rename this variable L, and then I searched for this word conic, and what I found when I got here was this is my variables, A, B, C, R, G, B, but I had to change it. So I just changed it to an L. That made it unique in the space. That's all I had to do. And I just had to change it 2 places, right there in the definition and right here in this color. Everywhere it asks about color, that's it. And that was the one mistake that the AI made. And what you get when you compile this code and run it is you get this slowly rotating cube. And here are my random conic sections. Now, I did not tell it to randomize these. I didn't tell it what shape. I didn't tell it to randomize the color. I didn't tell it the speed of to rotate the cube. I did not tell it the colors of the faces. That was part of the generative nature of the program. And so it just did this on its own. It was very interesting that it will just sit here and run, and that cube will slowly rotate in 3-dimensional space. And I could go in and manipulate that code or change its parameters. And in fact, I actually did that, and I'll show you where I changed it. There was the error that I did, but then I also looked for the cube was rotating quite a bit slowly, so I had to go through and read this code and try to figure out exactly where the cube rotates. And so what I did, I found this right here, update rotation angles. And so this was 1.1 and this was 0.2. And I just modified them a little bit because what we can see is that every time this loops, it's adding it's taking this decimal and multiplying it by the time. And so I just changed it a little bit. And that actually ended up making the cube rotate a little bit faster. And that's all that we needed. It's not as slow now. It's actually rotating a little bit faster. But this gives us a good, really good starting point to run. We can observe the code run. We can begin to read the code and see what is going on. And the interesting part about how AI did on this code is it completely used the comments, and it told us what each section of the code is doing. And so as a perspective of actually reading the code, we could read it and really get some more. Now, this is the rotating cube. And so I could spend a couple of hours reading through this code, and I could identify exactly where I might want to modify the code in order to have it do some other things. And then this would give me a potential capability to examine the SDL2 library and really ask some questions. What's going on here in this library? What are some things that I can do with this? And how can I make this work differently? How can I add or subtract? How can I get some user input to make these things happen? This is all automatic. I'm not doing anything with my mouse. This is all running on autopilot. But perhaps I want to add in some user controls and translate this cube, rotate the cube. That would be a starting off point to really get me down the road a little bit and understand what's going on, both with using an external library to run code and the compilation process as well. So AI did a really good job of giving me a simple program that I could use. It did kind of go above and beyond to do more. And so I was really pleased with the results. And it doesn't, as you can see, it doesn't take much of a prompt. Once you begin the process of actually asking it some questions, it will use those prompts to generate more and more detailed results. So give it a try and see if it can help you expand your knowledge. You could start with something you know and maybe move one step farther in the process. All right, thank you.